All right, hey everyone, especially you folks out there grinding away for those AWS certifications. Today, we're going to tackle a topic that it's absolutely central to being a good architect. We're talking about building systems that just don't go down. Systems that are resilient, fault-tolerant, and basically ready for whatever the world throws at them.
Okay, so picture this. Your app is live, everything's running smoothly, customers are happy, traffic is humming along, and then, bam, you get this, an outage, a big, fat error message, the dreaded silence. So what's your plan? Seriously, what do you do? Because let me tell you, in the real world, and you better believe this is true on the Solutions Architect exam, I hope it fixes itself, is not a strategy.
So here's how we're going to build that plan together. First, we'll talk about why you need resiliency. Then, we'll look at Route 53's role in all this. After that, we'll dig into how health checks work. We'll compare active-passive versus active-active, walk through a quick example, and then wrap up with the key things you absolutely have to know for the exam.
All right, section 1, the need for resiliency. Let's start with the big why. Why do we even care so much about this stuff? Well, it's simple. Every single second your application is down, you're losing money, you're losing customer trust, you're basically damaging your entire business. So, disaster recovery? Yeah, that's not some fancy add-on. It's a non-negotiable part of building anything professionally on the cloud. And when we talk about disaster recovery, it all boils down to these two key ideas, RTO and RPO. You're going to see these on the exam, for sure. So RTO, that's your recovery time objective. Just think of it as a question. How fast do we need to be back online? It's all about the clock. Then there's RPO, the recovery point objective. That one answers, how much data is it okay for us to lose? Maybe you can afford to lose the last 5 minutes of data, maybe only 5 seconds. Getting these two concepts straight is so important because they're going to drive every decision you make, and they directly impact the cost. Want a super low RTO and RPO? You can have it, but it's going to cost you more. Okay, so we get the problem. We need to avoid downtime. So what's the tool for the job? Well, at the DNS level, our hero is Amazon Route 53. I love the subtitle here, Your Traffic's Detour Sign. That's a perfect way to think about it. When there's a roadblock on the main highway, Route 53 is the traffic cop that instantly puts up a detour sign and guides everyone to a clear, open road. And that detour process, that's what we call DNS Failover. It's really that simple. A system automatically sees that your main server is sick, and without you lifting a finger, it reroutes all your users to a healthy backup. The key word, the magic word here, is automatically. No 3 a.m. phone calls, no panic scramble to change DNS records by hand. It just happens. So the next logical question is, how does Route 53 know that something's wrong? It's not magic. It needs a way to check. And that's where health checks come in. You can think of them as the eyes and ears of your entire failover setup. They're constantly watching, constantly listening. And the doctor on call analogy is perfect. Really think about it. You've got this dedicated doctor whose only job is to check the pulse of your application 24/7. It's just pinging it, asking, are you okay? Are you still there? And the second it doesn't get a response, the second that pulse flatlines, that doctor hits the big red alarm button. And you actually have a few different kinds of doctors you can hire, so to speak. The most common one is a simple endpoint health check. It just pings an IP address or a website. Easy. Then you've got these calculated health checks, which are pretty cool. They watch a bunch of other health checks, kind of like a head surgeon overseeing a whole team of doctors. And then there's the really powerful one, health checks based on CloudWatch alarms. This lets you trigger a failure based on anything you can measure in CloudWatch, like high CPU or low memory. These are the triggers that make the whole system work. Okay, so we know how a failover gets triggered. Now let's talk about the two main flavors of failover setups, active-passive and active-active. And listen up, because understanding the difference here is going to be huge for the exam. This is a classic topic. Let's break it down. On the left, you've got active-passive. Think of it like a primary server and a backup server. The primary is doing all the work, handling all the traffic, while the backup is just waiting. It's on standby. And for this setup, you use the Route 53 failover routing policy. Now, on the right, you've got active-active. Here, all your servers are working all the time, usually in different regions. If one goes down, no big deal, the others just pick up the slack. This model uses different policies, like weighted or latency routing. Okay, here's a great picture of an active-passive setup. This is what we call a warm standby. Don't let the diagram scare you, it's pretty simple. On the left, that's your main region, running at full steam. On the right, that's your recovery region. See how it's a smaller, scaled-down version? It's running, it's warm,
But notice that grayed out arrow from Route 53? It's not taking any live traffic. It's just sitting there, ready to be scaled up and take over the second it gets the call. Now, let's look at the active-active model. You can see the difference right away. Look at the top. The arrows from Route 53 are pointing to both regions. There's no standby here. They are both live, both serving users. So if one region gets hit by that lightning bolt and goes down, what happens? Well, the health checks will spot it, and Route 53 just stops sending traffic there. The other region doesn't even blink. It just takes all the traffic. The recovery is almost instant because, well, the backup was already running at full power. Okay, that's a lot of theory. Let's make it real. We're going to walk through a quick example of how you'd actually set this up. We'll focus on the active-passive configuration, since that's where you'll be using the specific failover policy. Honestly, it breaks down into just 3 basic steps. Step 1, you create that health check we talked about, point it at your main resource, maybe an EC2 instance. Step 2, you set up the DNS record for that main instance. You tell Route 53, hey, this is a failover record, and it's the primary one. Then you connect the health check to it. And finally, step 3, you set up another record for your backup, say a simple static error page on S3. You tell Route 53, this is also a failover record, but it's the secondary one. And that's it, you're done. Route 53 now knows exactly what to do when things go wrong. All right, let's shift gears. We've gone through a bunch of stuff. Now it's time to boil it all down to the absolute essentials you need to know for the exam. If you've been multitasking, this is the time to really focus in. First up, TTL. That stands for time to live. For your failover records, you want this number to be low. Think 60 seconds. Why? Because a low TTL tells all the DNS servers out there on the internet, hey, don't cache this information for long. Check back with me frequently. So when a failover does happen, everyone finds out about the new IP address really, really fast. Next, a little dose of reality. I love this quote. Downtime will never be 0, by the way. It's so true. Even with the best setup, a failover isn't instantaneous. It takes time. You have the time for the health check to fail a few times, plus the time for the DNS changes to spread across the internet. We're usually talking about a minute or 2, not 0 seconds. So it's crucial to manage those expectations. Okay, here it is, your final exam checklist. Let's run through it. Number 1, the failover policy is specifically for active-passive setups. Got it? Good. Number 2, health checks are what make the whole thing go. They're the trigger. Number 3, a lower TTL gets you faster failover, but you'll pay a little more in Route 53 queries. And number 4, this is a classic trick question on the exam, so listen close. If both the primary and the secondary are unhealthy, where does Route 53 send the traffic? It sends it to the primary. It defaults back to the primary record even if it's sick. Remember that one. And to wrap things up, I'm going to leave you with a little brain teaser to make sure you've really got this. We know the failover policy is designed for active-passive, but could you get the same result using weighted records instead? Think about it. How would you set the weights on your primary and secondary resources to make one the primary and one the standby? It's a great exercise to connect the concepts. All right, that's it for me. Good luck with the studies.